In this video clip, we'll look at two identities. Let's consider the right triangle POM. This right triangle. We know we have a PM. Let me write this one. PM squared, this side squared, plus OM squared. OM is this side squared, is OP squared. OP is the hypotenuse. We also know this is a unit circle, so the radius, OA, you see A coordinate, X coordinate of A is 1, So here it then tells us OP is 1, okay? But we know OP is 1, that will be 1 squared. And P has coordinate pxy. So PM is y squared. And OM is x squared. OM is x. And we know PM is y coordinate. Y coordinate is sine. So we have a sine alpha, that's y. In the union circle, PM is y coordinate, which is sine alpha. So sine alpha squared plus x, x coordinate is OM, so will be cosine alpha squared. See if I can do it better. Erase this one. Rewrite it. So that will be cosine alpha squared is 1. So this will be one of the identity we need to know today. It is true all the time. To see the animation here is that this one, on the left-hand side, P here was in the first quadrant. So here the case is the same. It can be in the second quadrant. Okay, but OP still is the radius. Okay, and then we have a PM, y coordinate is sine. OM is cosine. Okay, and then we have in the third quadrant, in the fourth quadrant. It is all correct when P is in a different quadrant. Okay, and we also know is that tangent alpha is defined as y over x. Okay, but we know again y is sine alpha and the x is cosine alpha. So it is true that tangent alpha is always equal to sine alpha over cosine alpha. Okay, so this will be our first identity here. And this will be our second identity. So it is very important identity. We're going to use this one a lot. Okay, but here remember, PM is y over OM is x. Previously, we know that when the angle alpha is fixed, the ratio rise over run PM over OM, PM over OM is TA, T this point and A this point. So TA this one over OA. Over OA. OA is 1, OA is 1 here. So that means PM over OM is actually equal to TA. TA. Okay, TA, this one. So TA is also called tangent line. Let me write tangent for TA. And OM is also called cosine line. And PM is sine line. Okay, PM, because PM over OP, and OP is 1, so PM is also called sine line. And then OM is cosine line. So there are 3 lines. TA, this one, tangent line. PM, sine line. OM, cosine line. Okay. All right. Let's see some applications. We scroll to somewhere here. Let's look at the example right here. So I will move the example in. Okay. See if I can do like that. Good. It fits in. All right. In this one, we know sine alpha is given as negative 3 over 5. Okay. Then we know previously is sine alpha plus cosine alpha is 1. Now we take sine alpha squared to the right hand side. Then we have this is true. You know, previously we have this formula here. Okay. We then take, in this case, we take sine alpha squared to the right hand side. So we then have this one. Okay. And then 1 minus sine value is given is negative 3 over 5 squared. And then we have a 1 is 25 over 25 minus 9 over 25. Because negative 3 squared is 9 and 5 squared is 25. Here we have a parenthesis negative squared, so we get still positive. This negative sign is the one right here. Now 25 minus 9, it gives us 16. Denominator 25 are the same, so we write 25. So when you do the subtraction for fractional numbers, you only minus the numerators if denominators are the same. So this is we get for cosine alpha squared. Okay. And then we need to choose the square root. Okay. So then cosine alpha has 2 situations. Okay. When is what? When is negative? When is negative? How to take this one out? Okay, it's out. So we'll have choose the square root. We have 16 over 25 could be negative 4 over 5, or could be positive 4 over 5. Okay, there are two cases. But previously we got tangent alpha is sine alpha over cosine alpha, and the sine alpha is negative 3 over 5, which is given here. So at the case when cosine alpha is negative 4 over 5, we then have a negative. So we then get positive. When you do the division, you flip the second fraction to 5. Denominator 5 goes up and 4 goes down. Okay, cancel 5. We then have a 3 over 4. Okay, here for the second expression is the same. The only thing different is cosine alpha is positive 4 over 5. And then in this case, we have a negative because only one negative here. Then it's going to be 3 over 4. So we have two answers. Okay, so cosine alpha is x-coordinate of point P in the definition. So when alpha is in the fourth quadrant, we then have an x-coordinate of the P is positive. Recall what we learned before right here in the definition. You see this angle, this point P is in the fourth quadrant. So the OM, the cosine line is positive. So that's how we complete this example. Okay, I'll see you next time.